Okay, we are now going to talk about some of the material contained. We are now in Chapter 5, 3 sections, and let me tell you from the start, there is an incredible amount of information in these sections. As I was trying to outline topics to cover, I was amazed at how much stuff is there and how much time it would take for me to try and explain it adequately, so I'll do my best. I may not be able to cover every single topic in the homework, but like I said, let me get started and explain as much as I can, do a few example problems, hopefully explain some of the things that are going on. A big part of this, we start out with talking about polynomials. So let's first define what makes an expression a polynomial. Sometimes it's easiest to just give examples and then describe why something is or is not a polynomial. So this is my function notation. This is probably the kind of equation you've seen before. This is a polynomial. That's a polynomial. Turns out this one is not a polynomial. So let's talk about what makes something a polynomial and some definitions. Polynomial, you have one variable, and the key is to look at the exponents. For a polynomial, exponents are integers and the number 0. For example, exponents are 0, 1, 2, 3, almost like counting numbers. That's really the whole key to whether something's a polynomial or not. Once again, no fractions are involved as this goes. So for instance, here the polynomial, the exponent's x squared, that's fine. 2x, there's really a 1 here. If you think about this, you could think of x to the 0, which of course is 1. Here, I'm okay. This is the problem. If I have to write this with an exponent, if you remember, this would be x to the minus 1. This is not allowed as one of the terms of a polynomial. Now sometimes you can be a little fooled. Sometimes you may be given an expression like this, and you're asked, is this a polynomial? And at first you think, well, it looks like a fraction. Well, it is a fraction. However, there's no variables in the denominator. We could split this up into two separate fractions, and this in fact is a polynomial. The key to determine if it's a polynomial is looking at the variable. The numbers in front of these terms are called coefficients. You've maybe heard that before. Now we have something that you may hear about called the degree of a polynomial. The degree of the polynomial is simply you determine the largest exponent on the variable. So if I have here are 3 polynomials. These are all polynomials. This would be, my largest exponent is 2. That would be called a second degree polynomial. Here, my largest exponent of the variables are 1, first degree. Here it's 4, fourth degree polynomial. And by the way, something I assume you already know, but we always write polynomials in what's called descending powers. That means your largest exponent is first, and then you write the exponents begin to get smaller and smaller as you move to your right. Now we call numbers in front of the variable as coefficients, but there's a special coefficient. The leading coefficient is the coefficient in front of the first term. We oftentimes actually call this the leading term. So leading term, leading term, leading term. In this case, the leading coefficient's a 2. Now for these polynomials, the leading coefficient's 1. Because you could think of a 1 being there. Alright, so those are some definitions of what a polynomial is. Now, we're going to start doing some math with polynomials. And just so you know, you're going to see me do this occasionally as I do some problems. Here's an equation or a function written in function notation. Remember, and sometimes this is going to be helpful to us, you can always replace f of x with y. We're going to be doing some graphing of polynomial functions, and oftentimes it helps, or it's a little more understandable if we talk about y instead of f of x. Matter of fact, the first thing I'm going to talk about, it actually makes more sense if we use y instead of f of x. So here's one of the first topics that you're going to have some homework problems on, and we're going to use it a lot. That's called intercepts. Let's talk about the concept of intercepts. And normally we say there are 2 kinds of intercepts. We have x-intercepts and y-intercepts. Let me show you visually what an intercept is so you can picture it, which hopefully will help your understanding. Say I have a function, just sort of a random graph here. You can think of this as some function. The intercepts are where the graph crosses either the x or y axis. Intercept sounds a lot like intersect, same root word. Here you can see the graph crosses the y-axis. Therefore, that point, the point where the graph and the y-axis intersect, that would be called the y-intercept. Here, the graph crosses or intersects the x-axis, therefore that's the x-intercept. You may have like a parabola. If you were to look at this and you were told, go point out the intercepts, you actually would have a y-intercept right here, Turns out you would have two x-intercepts because the graph crosses the x-axis in two places. Now here's something that can sometimes confuse students with the notation when you actually try and list what the intercepts are. For instance, let's just look at this problem here. Say it's 4 right there, and this is maybe -4. If you were given this graph and asked to list the intercepts, here's one way you could do it. You could give it, which is very common, and I think a lot of times in the homework this is how they want it, and they will tell you a lot of times what form they want the intercept to be in. A lot of times they will say give it as an ordered pair. Ordered pair means like a point on the graph, an x and a y. So we would say for the x-intercept, x is -4, y is 0. For the y-intercept, x is 0, y is 4. That's very, very common how they ask for the intercepts. But there are times, either as an answer or sometimes in a problem, they will often just say the x-intercept equals -4. Well, sometimes that can be confusing because we just talked about the x-intercept is like a point. You've got to have your x and your y. But down here, they just give the x-intercept as a number. So what's up with this? And are these the same? Well, they are the same. What they do here, this is almost sort of like shorthand, because you know what? For every x-intercept, what is the value of y going to be? For any x-intercept, it's where the graph crosses the x-axis. What is y going to be? Y is always 0. So it's almost like sometimes in the math world they say, why do we want to keep writing -4 is 0 when, because it's an x-intercept, you know y is going to be 0. We'll just give you the important information. We're just going to give you the value of x. The x-intercept is -4. -4 really is -4, 0, but we don't want to write the whole thing. Let's just write this. And they would turn around and say, the x-intercept is 4. Well, they're saying because it's a y-intercept, at a y-intercept, x is always 0. So when we give an ordered pair, they call it 0, 4, but a lot of times it's like a shorthand. They'll just say the y-intercept is 4. So you just have to be careful. Oftentimes, especially when you're answering a question on the computer, you need to make sure it's in the form they want. I think initially, a lot of times they will ask for the intercepts as ordered pairs. But in some problems, and maybe future problems, maybe they'll just ask for the intercepts as numbers. We don't know. Okay, so that's visually what intercepts are and even how we write them. Now let's figure out, if you're just given equations or functions and you're not given a graph and you don't want to create graphs, how can you just quickly calculate intercepts? And it's actually very simple. Let me give you the steps real quick. So here are the steps for finding x-intercepts, and here are the steps for finding y-intercepts. And let me give you a couple of examples. We'll do this one first. So you notice I'm going to write my equation with x and y. I could call the y f of x, but I'm going to make it y just to make it clear since we're talking about x and y intercepts. Here are the steps. If you're given an equation or a function and you're asked to find the x-intercept, for an x-intercept, you go to your equation and you set y equal to 0. and then you solve for x. And that x will in fact be your x-intercept. So it's almost like, since we know at the x-intercept y is going to be 0, we go ahead and set y equals 0 in our equation. And when we solve for x, that's the x-intercept. So for this one, to find the x-intercept, set y equal to 0. And I'm going to solve for x. I would say the x-intercept is negative 1/2. If they wanted it as an ordered pair, negative 1/2, 0. Now the y-intercept, it's like you just flip them. Since you're looking for the y-intercept, the first step is to set x equal to 0. And then you solve for y. And when you solve for y, that y is actually the x-intercept, or the y-intercept. So once again, for this one, to find the y-intercept, set x equal to 0, so y equals 2 times 0 plus 1. Of course, this is 0, so y equals 1. So 1 is your y-intercept. If they want it as an ordered pair, you would say the y-intercept is 0, 1. Okay, so finding the x and y-intercepts of an equation or a function is pretty simple. Let me just do one more example. It's got one little twist to it. How about if you were given this equation? A lot of times they'll just say, find the intercepts. Now when they say that, we know there's two types of intercepts, x-intercepts and y-intercepts. So we want to find both. So for the x-intercept, you set y equal to 0. So 2x squared plus 2 times 0 equals 0. Oh, I wrote this incorrectly. Sorry. This was turning out not like I thought. I was confused as to why. Sorry. Should have been 2x squared plus 2y equals 8. Now, to find the x-intercept, set y equal to 0. 2x squared equals 8. Divide both sides by 2. X squared is 4. Now we want to solve for x. How do we do this? Don't forget two things. How do we solve for it? Take square root of both sides. But even more importantly, when you take the square root of a number, it's not 2. It's plus or minus 2. So there are actually two x-intercepts. 2 and negative 2. And actually, I think in the online homework, they don't allow you to put plus and minus, so you'd have to actually put 2, 0, negative 2, 0. So there are the two x-intercepts. How about the y-intercept? Well, you take your equation and you set x equal to 0. So 2 times 0 squared plus 2y equals 8. And now we're going to solve for y. This is 0. You have 2y equals 8. Divide both sides by 2. There we go. So the y-intercept is 4, or if they want ordered pairs, 0, 4. All right, so intercepts. That's one of the things that you're going to be doing over and over again. You may have one or two problems where you're just finding intercepts, but later on it's going to be one part of a multi-step problem, finding intercepts. All right, not too bad. Now let's go back and take a deep dive into all the different things that we're going to want to investigate and understand and learn. We'll call this polynomial functions. In a minute, we're going to look at some polynomial functions, and these are some of the things that we're going to try and determine. Let me write down what we're going to be asked to find, and then I will try and define them, and we'll do some examples. Here are the things they're going to ask you about. They're going to give you a function. So for instance, let me just write down the first problem we're going to solve. Pretty straightforward trinomial. So we're given this function, and here are the things that we're going to try and determine. We're going to figure out what they call the zeros. We're going to figure out something we just talked about. They're going to ask us to determine the x-intercepts of this function. Something else they're going to ask us to determine are the factors of this equation. And then one more concept which we can talk about, the solutions to this equation. Here are 4 different things, but you're going to see in a minute, even though there's 4 different words, different sort of things we're looking for, they're all pretty much the same thing. It's just a different twist on the same idea. So let's just start with working through these and see how it relates to this function. Now the first thing in this section, everything we're going to do, you almost always have to start out by factoring. If you can't factor, then a lot of the stuff we're asked to determine, we're going to be sort of stuck. So the first thing you always like to do is factor. So let's factor this right away. It turns out this is a trinomial I can factor. So once again, 2 numbers multiplied together equal -4, but when you add them equals 3. And I believe x plus 4 times x minus 1. If you multiply these two out, you get this right here. Now first, looking at this now, they say the zeros. Another way to write it is the zeros of the function. Sometimes they may say the zeros of f of x. Basically, a zero is the value of x that causes the whole function to equal 0. In other words, let's go find a number for x, and maybe there's more than one. The number of numbers for x, that if I plug that number into my equation, the whole thing equals 0. So it makes sense that they might call this the zeros of the function. What are the values of x that cause the whole function to equal 0? Now the way we do that, let me rewrite our function in factored form. To find the zeros, basically you set your f of x to 0 and you solve for x. Makes sense, because what we're doing, we're trying to figure out the values of x that cause this whole thing to be 0. Hopefully, you guys all find this pretty easy. The solution to this would be -4 and 1. So these are the zeros. Now I just said the word solution. These are also the solution to this equation. And that was one of the things that they like to mention. I started with zeros, but one of the words here was solution, where you can see where zeros and solution, basically the same thing. Once you set your function equal to 0, you can solve it, and when you solve it, your solutions are basically the zeros. Now what's interesting is the zeros are the values of x that cause the function to be 0. Let me rewrite our original function, and just for fun, let me replace f of x with y. Now say I gave you this equation. I said find the x-intercepts for this equation. Thinking back to what we just talked about, how would we find the x-intercepts? What would we do? We would set y equal to 0 and solve. Well, you know what? What did we just do up here when we were finding the zeros? In this case, we said we were going to set f of x to 0. Well, f of x and y are the same thing. So to find the zeros, we set f of x to 0 and solved it. Now to find the x-intercepts, what did we do? Set y equal to 0 and solved it. We're solving the same equation. What does that mean? That means that really x-intercepts and zeros are the same thing. It's just a different name. It's like flip sides of the same coin. If you're asked to find the zeros, that's the same thing as finding the x-intercepts. If you're asked to find the x-intercepts, that's the same thing as finding the zeros. So when we look at these 3 words, or 4 words, zeros, x-intercept, solutions, we've covered the 3 of these. What's this thing about factors? Well, the first thing we did with this problem, if we go back here, initially, this was the initial function. And what did we do? We factored it. Now what happens when you factor an equation? When you have a factored equation, remember I said, let me try and make this clear. Let me put down the official function. And I said we're going to factor this. And remember I said, what are the 2 numbers that multiplied together? So I'm looking for 2 numbers and multiply them together. They equal -4, but then the same 2 numbers, when I add them together, have to equal 3. The numbers that do that trick, those numbers we call factors, and in this case, we found the factors to be right, 4 and -1. And once we find the factors, then we can rewrite the equation in factored form. But you notice I called these the factors. So therefore, when I look at an equation like this, if someone gives me this equation, it says what are the factors? These numbers here are the factors. So once again, let me say it again. When you have an equation that's been factored, the factors are the numbers sort of like inside the parentheses. What if I have what if you were given this factored function that's been factored, and you are asked what are the factors for this? You would say -1, 7. Now, does this one have a factor where you know what x is? If I wanted to think of it like a parenthesis, how about I could think of it as x minus 0? So I actually have a factor of 0. So these are the three factors. Now you notice for this equation, the first one I started with, I found my factors to be 4 and -1. What did I find my zeros and x-intercepts to be? -4 and 1. What happens is zeros and x-intercept, if you take the opposite sign, you get factors. So if I look at this equation, I said the factors are -170. What are the zeros of this equation? Well, the zeros would be what values of x would cause this whole thing to be 0. It'd be 0 and 1 and -7. Lo and behold, the zeros of this function are just the opposite of the factors. And that's how it works. Zeros and x-intercepts, which are the same, are opposite signs of the factors. All right, I know that was a lot. Now what we're going to do, I think I'm going to stop now, and I'll pick it up in the next video. Based upon all the stuff we've just learned, now we're going to start doing some work with some equations and even trying to derive some equations. So let me stop for now, and we'll pick up again in the next video.